Welcome viewers. Today we are going to start with chapter 7 of class 8 mathematics, cubes and cube roots. Cube of a number is the number obtained by taking the number 3 times and multiplying them. So if a number is a and we multiply the number with itself taking the number thrice, we get cube of the number. Similarly, cube root, we write it like this, is inverse operation of cube. So suppose this number a cube is equal to x. So cube root of x is equal to a, the inverse operation. Clear? In previous exercises, we have seen to find square root, we need the numbers in pair while doing prime factorization. In this case, we'll be requiring triplet because the number has been multiplied by taking them in threes. Clear? One more concept. Every number, every natural number is either a prime number or its multiple of prime number. That means, suppose we take 6. 6 is not a prime number, but 6 is equal to 3 into 2. Both these are prime number. This makes our calculation faster. This concept will be requiring while solving the steps in a faster manner. Similarly, if we take 10, 10 is not a prime number, but 10 is equal to 5 into 2. So both the factors are prime. So all natural numbers are either prime number or they are multiples of prime number. Clear? Exercise 7.1, question number 1. Which of the following numbers are not perfect cubes? So we apply prime factorization method, but in this case we desire to get the factors in triplets. Okay, so let's proceed. So we start with 2 here, we'll get 1, 0, 8. Again 2, we'll get 5. Again 2, we'll have 2, 7. We'll apply. Divided 3, we'll get 9. Again with 3, we'll get 3. Again with 3. So we have obtained the prime factors. Now let's see, they are in triplets. Yes, these 3 in triplet, these 3. So we can write this as, we got the number divided by prime numbers, and we can write this as 2 cube into 3 cube, that is 6 cube. So this number is cube of 6, hence this is a perfect cube number. Clear? Same way, let's leave this number. Let's start with again 2, 6, 4. Again with 2, we'll have 3, 2. Again with 2, we can get. Again with 2, we'll get 8. Again with 2. So we have completely divided this number. Let's see, does this number exist in triplet? This is triplet, this is triplet. So we are left out with 1, 2. So you can write this as 2 cube into 2 cube into 2. Since they cannot be expressed in cubes as they don't exist in triplet, this number is again not a perfect cube. Clear? Taking this number. Suppose we keep on dividing with small prime numbers, we take a lot of time. I've just told that all numbers are either prime number or multiples of prime number. So apply this concept here. We take 10 straight away. So we'll have 100, again 10, we'll have 10, we'll have again. So we get a triplet of 10 here. So we can write this as 1000 is equal to 10 into 10 into 10. Okay. And later we can prime factors. 10 is equal to 2 into 5. Both these are prime number. Again this 10 is equal to 2 into 5. Again this 10 is equal to 2 into 5. Clear? So with this concept we are able to solve the problem fast. And we see here that this 2, this 2, this 2, they are in triplet. Okay, so this is 2 cube This 5, this 5, this 5. Again in triplet, so we can write this as 5 cube. So we get 2 into 5 cube, that is 10 cube. So 1000 is again a perfect cube. Clear? Now let's see 100. We'll apply the same concept. 10, 10, and 1. We write it as 2 into 5 into this 10 as 2 into 5. 10 into 10, we got the factors. So getting the prime factors, we see that they are in pair. So this is 2 into 2 into 5 into 5. So they are not in triplet. So we cannot express them as cubes. Hence 100 is not a perfect cube. Clear? Moving on to this question. Such a large number, if you use starting from say 2, 3, it will take 10. So let's see, we move faster with 6. So we get here 7. Again 4 balance 7, 42. 6 7 is 42. 7. So we get 4 balance 45. Again a 7. We get a balance 3, 36. We get a 6 here. Again divided 6. Here we 1. Here we get 2, 12. 5 balance 57. We have what? 54. 9s are. Sorry. Yeah, 54. 3 balance. So 54, 57 balance 54. 3 balance 36. So we get here 6. Again we divide 6. So 2 here, 1 here, 6 here. So 216. We have recently solved this. 216 is already 6 cube. So can we move faster? Again divide by 6. We'll get here as 3, 6. We again divide by 6. We get it here 6. Again divide 6. We get 1. So this 3 6s and these 3 6s are in triplet. So we can write this number as 6 into 6 into 6, that is 6 cube, and this 6 as 6 into 6 into 6, 6 cube. So we have moved very fast by taking 6 as divisor. And we can write this 6 is not a prime number, but 6 is equal to 3 into 2. Both are prime number, into this 6 is equal to 3 into 2. Both are prime number. So we apply the prime factorization in a fast way. And we see that here we have got 6, so we can write it 6 into 6, that is 36 cube. So this number is cube of 36, hence it's a perfect cube. Clear? Question number 2. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect square. So I have already derived the prime factors of the number. Let's see. So in this case, these 3 are in triplet. So we get here 3 cube. This is not in triplet, they are in pair. So we require one more 3. Okay. So we'll multiply this number with 3, and then we'll get another prime factor of 3, and hence it will be a triplet of 3 again. So we require to multiply this number with 3 to get a perfect cube. In this case, in triplet, these 2 is in triplet, this is not. So if we multiply this number with 2, so we'll get another 2 here, and this will form a triplet. So 2 need to be multiplied to make it a perfect cube. In this case, in triplet, not in triplet. So you require another 3, so that this can be 3 cube. So 72 need to multiply 3 to make it a perfect cube, and the smallest number will be, of course, 3. In this case, we see this 3 is in triplet, so you can write this as 3 cube, and this 5 is not. So we'll multiply this number with 5. The smallest number will be 5, and we'll get another factor 5 here, and this will be 5 cube, and this number will become a perfect cube. Taking this number, this time we have not jumped the steps by taking a larger one. We have gone by the convention rule, because in the question we have been asked the smallest number need to be multiplied to make this number a perfect cube. So we see here these 2 They are in pair, not in cube. So we'll require a 2 to make it a perfect cube. And this 5 is also in pair, so require another 5. So we need to multiply 100 with 5 into 2, 10, so as to make it a perfect cube. Clear? Question number 3. Find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. So prime factorization already done. These 3 are in triplet. We have got one extra 3. So if we divide 81 by 3, we will get rid of this 3 and we'll obtain here 3 cube. Okay, and this 3 cube of course will be a perfect cube. So we need to divide 81 with 3 to get a perfect cube. In this case, these 2 in triplet, these 2 in triplet. So you've got 2 cube here, 2 cube here. This 2 is extra. So if we divide 128 by 2, we'll have our factor still here and this number obtained will be a perfect cube. So 2 need to divide 128 and 2 will be the smallest number. In this case, we have got 3 in triplet. So we can write this as 3 cube. 5 is extra, so if we divide 135 with smallest possible number, that is 5, we'll get a perfect cube. In this case, in triplet. So this 3 is extra. So if we divide 192 with 3, we'll get a perfect cube. And this 3 will be the smallest number possible. We can divide 192 to get a perfect cube. Clear? That's in this case, in triplet. So we are left out with 11. If we divide 704 by 11, we'll get a perfect cube. Clear? Question number 4. Parikshit makes a cuboid of plasticine of sides 5 cm, 2 cm, 5 cm. How many such cuboids will be needed to form a cube? This is the structure he has made. Here, 2 dimensions are same, height and base. One side is not same. So, cuboid is a structure where it is not a perfect cube, but it's cube-like. Okay. And to make this, he has used plasticine, a plastic derived material which can be molded to form various structures. So, we have been asked how many such cuboids will be required. That means, let's find the volume first. So, volume of this cuboid will be 5 into 2. This is volume of the cuboid or amount of plasticine which has been used. Now, if he keeps on joining similar structure in such a manner, all the dimensions, all the 3 dimensions of the obtained structure are equal, he will get a cube. So, every time he adds, it will be the volume which will be added. So, this is the volume of the cuboid. Now, let's see how many such volume will be required to finally mold the structure into cube. So, here you can see 5 is in pair. So, if we multiply with another 5, we'll have triplet. So, this volume component will have a triplet in it. That is what we desire. Again, if we multiply 2 2's, we'll obtain triplet of 2 also. So, we can write this as 5 cube into 2 cube, that equals to 10 cube. So, we have obtained a cube whose dimensions are 10 centimeter. And this is the number of these kind of cuboid which will require to form this cube. So, let's see how many such cuboids will require. This will be 5 into 4, that is 20. So, 20 cuboids will be required to form a cube whose dimension will be 10 centimeter. Clear?